Yeah, so today we'll cover two things. One is node selector, second is annotation, then some generic errors, and then I think one more thing I'll show is how to create multiple containers, one pod with multiple containers. It was an assignment, but I will show it in the current session. Once that is, and that's all we'll cover. So that more or less will take care of pod. Then what I will show you is the IntelliJ plugins which I have been using. Those are pretty good actually. One is for Docker and one is for Kubernetes. There is a Google plugin also for Kubernetes that it just does not. That's mainly for Google Cloud. But if you are if you have Kubernetes set up on your local like Minikube or something, or using Docker desktop, it will show you that as well. So I will show you that on IntelliJ how it works, and it's what all the facilities they provide. So it will be pretty interesting. So now we'll start with the node selector. So node, we discuss label selector on the pod. Now it's node selector. So node selector is the nodes on the worker nodes of the pods of the Kubernetes cluster. Now you can label those as well. Generally, pods creation should not be tied to any node. And why do you want to label those? Because you want a certain pods to be created only on those nodes which have those labels. As a principle, you should not be tying your pods to labels, because when pods get crashed, then Kubernetes will start that pod automatically. So it should be able to give any node to that pod. That pod should be able to get started on any node. But sometimes we want to have, I have given example below, we want to have, we want to tie our pod to certain nodes. We will not give the node IP or node thing, that anyways we not possible, and even if it is possible we should not be doing it, but at least certain type of nodes it allows us to specify. Examples, I want my pods to use nodes which have SSD, or which have the nodes which have GPU. Now Kubernetes is not providing mechanism to go and check whether it has SSD by running operating system command or check whether it has GPU processor. It does not provide any of that. What does it provide is you can label certain nodes with these SSD or GPU, and then later you can tell pods that start this pod on those nodes which have this label or these labels. Okay, so we'll see that. So we'll run this command. First, what we'll do is we'll get all the nodes using this command. Now, because I am showing my local, I will be able to show, there is only one node which is running. So on that, so this command will result only one node itself. Then you can label, one or more labels. You can have one or more label on the nodes. So this is a command kubectl label, and now you're specifying a node, and this is the node name. How did you get this node name? By running this command. And now you're labeling it GPU equal to true. And then you can, once it's labeled, then you can say whether this node has got this label or not. So let's see. I will run these commands now. I'll go to the command line. Let's remember kubectl get node. So help me with this. Kubectl get nodes. It's showing that the name is Minikube. Let's see if I might have done label this. I might have labeled this already. No, I have not labeled this. That label which we're talking about, I have not done that labeling. I have done some other labeling. But let's go back to our this thing. So show labels shows this, and if you don't give show label, it will not show the labels even for nodes also. Well, like this is a similar thing which we discussed with pod. Now we're discussing about the real nodes. Now I will assign this label later, but I want to check whatever label I'm using. So here I'm saying create a pod. So this is a pod creation, right? V1 pod, and spec node selector. I'm giving a node selector now. So create this pod only those nodes which have node label as GPU equal to true. So I'm going back. So I will run this kubectl label node. Kubectl label node, and this is the node name Minikube. and I will say GPU equal to true. Okay, I think somewhere GPU equal to true is already here. Do you see app name Kubernetes to commit? I'm not seeing that somehow. GPU already has a value true and overwrite is false. Let's say, I don't know, or okay, because it's the same value. If I change it to false, let's say, change it to false, we'll play around with this. So now it's labeled. Now I change it to true back. So now it's unlabeled. And let's see the label again. Somehow it has a limits on a number of things which it show. So we have to describe node and then let's see if that works. Okay, these are the labels. Now these are the namespaces it's part of. Okay, it start on the second line. Sorry, let's see that. Oh, yes, it's here. I missed it. So this is the label GP equal to true. Now what I will do is I have this not namespace. I have this file. I think I have the name of the file also here. Node selector. So let's open that. Cat node pod underscore node selector underscore node selector YAML. So here you see this pod I'm creating and I'm telling node selector GP equal to true. Now let's try to run this. So let's try to see existing pods we have. kubectl will get pods, and you can see kubectl will get PO also, by the way. It works. So forget about GU quarter job. I have this now running for some other purpose. I will come to the jobs. It's very interesting. It's completely it's not error or something, and the status will just we'll come to that when we reach the job. But now these are the 3 pods I have running. So I will start this pod also now. Not this. kubectl create -s. So now I will go here. Okay, let's go. Now let's see the pod first. Pod got created or not. I can say this. Now pod this for GPU got created because this is the name I had given here. Java Docker SKS for GPU. This got created. Now let's go back to our slides. This we did. A check pod inside a particular node using this command. So let me copy this command if I can. Okay, I can't. This is annotations. Let me do this. Now I should be able to copy. This is a big command, so I don't want to write myself. Check pod inside a particular, and it will tell me. I'm just trying to see the node which I selected. So I will just copy this command. Okay, on the Minikube. Okay, these are the pods which are running. Somewhere our pod is also there. This one, and this is running on Minikube, right? So you can check this is running, and it's running on Minikube. It got started only 1 minute before approximately, and things like this. So you can check pod. This is you can label the node first. I will summarize. You can label the node first, then use the node selector command in your pod. So we'll look at it one more time just to revise it. There is cat command on this one. So here we are using the node selector and give this label name and the node label name and node label value, and then validate using this command. So that's our about node selector. Now see containers inside a pod. This is unrelated. If I want to see containers inside a pod, then I want to run this command. I want to see container inside this pod only, which I got started. I mean, this is just a JSON path. If you use pod describe give you all the information about the pod in JSON way. So you can if you want to see any of those information, so you can take the JSON path for that information you want to see and pass that here. So I'm using the container name. I'm just getting the container name. So I will run this. Okay, this was already there. So I will run this. Okay, so not second time. It's describing the port, trying to go to the JSON and trying to get this information. So it might take a while. So while it's running, let me go back here. Go to the slideshow. Okay. Slideshow. Let's see if that is over. It's still running. Somehow it's still running. So let's wait. Okay, back. So that's about the node. Now we have something called annotations. See, we discuss about labels. We discuss labels in the port and we discuss labels in the node. Now these annotations, labels have key value pair. Annotations also have key value pair. So there's a similarity that with labels. But one of the things is annotations, you don't have annotation selector. Like, you have label selector while creating the port, etc. Here you don't have the annotation selector. Now, why generally annotations are used to store large information. So you can annotate a port using this command or via YAML. So this is so kubectl annotate port and give this port name and give this annotation, whatever. Now, generally, you use annotations when you want to, you're testing something, and that testing is, there's a feature flag, or and you want to have some ports which have those feature flags, so that you can identify. So that's one case. Other case is because it can store large information. If there's a huge information you want to store, I don't know, based upon use case to use case. For example, want to want to annotate the context of that pod, what this pod does, what is supposed to be doing, and all sorts of things. So you can mention that in annotation. It has no bearing on anything else. It just say metadata. So what we'll do is annotate pod. Let's annotate this pod only, and we'll get the port name from here. It errored out for something. I don't know. Maybe I have only one machine running, so it might be timed out. So if I try 2-3 times, then I might be able to get. But we'll try it later. So I will annotate the same port, kubectl annotate port. Port. And I have to give the name. So I will give some arbitrary name. Let's say testing for advanced. I can say testing this one. Is it both are double quotes? No. So testing for advanced features. Advanced TURES. I can say feature flag equal to, right? So it got created. So now moving on from here. So if I get this complete port information, and I say -o YAML, let's see what it does. kubectl get port, and I give this name. I had this here only, I think Control V, yes. Then -o means output, give output in YAML format about this port. So I hope it doesn't time out. Good, it doesn't time out. So here you can see all the information about this port, and somewhere it might be having annotations as well. These are the annotations. So in metadata. So this annotation, this is what I get, feature flag testing for advanced features. I have given only the small sentence, but it could be, big JSON, huge big JSON also if you want, or huge big list of sentences also if you want, correct? So that's about annotation. And what's the purpose of annotation? Again, repeating, just, there's no annotation selector. It is just to store some metadata where the pod creator might want to remember, for example, or the pod user might want to look at it. There's one feature flag which is still under testing, so don't use it. Or there's some advanced information if you want to check for pod, who approved certain things and all those things. If you want to keep it, it's all your business use case. So that's what you keep in the annotations. Moving on. Somehow my system is very slow today. So namespaces. Namespaces is very widely used in organizations. So are generally used. You split objects into separate non-overlapping groups. One example could be, we discussed in the teams in the labels also. Namespaces is one where I want to allocate resource. Let's say I have 10 teams working, and I want to say team one is is working on a financial or legal project, which it has to take it has to get all the maximum resources, and it always should run on priority or something like this. So that's where I will assign different namespace so they don't interfere. These ports execution don't interfere with each other. So it split objects into separate non-overlapping groups. It's known as, if you know Linux namespace, is not that. It helps. So there are multiple use cases why you might use a namespace. It helps split complex system into many components. That's one possibility. It can be used for separating resources into multi-tenant environment. So the example which I gave is the application within a company, but multi-tenant environment is, for example, I am hosting a subscription-based business where people can come and subscribe to what I'm offering, software offering I'm giving, they subscribe to that. Now for each of these are tenant for me, each of these users. And I might have premium subscription, I might have gold subscription, and I might have standard subscription. So I might assign more resources to premium subscriber, little less to gold, more or less to standard or something like this. So that could be one way. It can also be used to control access to certain resources by user. For example, someone is working on financial data, some system is working processing the financial data, and no one else needs to access on that. So I can assign a separate namespace and not give permission to anyone else to access that namespace. And this we already discussed, also for limiting amount of resources for individual users. Now we'll run this command kubectl get namespace, and we'll see already some existing namespace should be there. I think I already ran this somewhere, but I can run this again. So these namespaces are created by Kubernetes. kubectl get namespace. So these are the namespaces we have. One is default, and these some are created by Kubernetes or something like this. Now what we are going to do is, if I want to get ports belonging to particular namespace, then I can give this. So let's say kubectl get port is equal to cube system. So these are the namespaces. I want to see what are the ports inside one of these namespaces. So cube, this one is system. So these are the ports which Kubernetes only started, Kubernetes is maintaining, but these ports have these namespace. Correct. So similarly, I can see for, I think we might have the whatever ports I had running, those will come under default because I had not assigned namespaces. Yeah, these are my ports which are running. Some are completed, some are continuous starting. So these are the ports, and this is just starting now. Okay. So this is the namespace, and remember all of this, all of this you can do using API also, using YAML also, using command line as well. So any of these, we are focusing more on YAML, and subsequently much later in our sessions we'll take some examples of the APIs also. So you could use either of these. So this we have done, create namespaces, I said, via YAML or using create namespace command or via API. So I will show you one example. So let's see. Control R, I have just written it. So this is the one file which I had, a YAML file. So I'm creating the, so I can give some other name to this pod which is getting created, Java SKH namespace or something, namespace, save. Then of course everything else is same. I have just given the namespace as my namespace here. So let's run this. Okay. kubectl create namespace.